Have you ever really stopped to think about what happens in that split second after you click a link? I mean, really think about it. Today, we're going to trace that incredible, invisible, high-speed journey your data takes, from your device all the way to the cloud and back again.
It just feels instant, doesn't it? But behind that one simple click is this hidden world of digital logistics moving at the speed of light. So let's pull back the curtain and see exactly how it all works. All right, so the journey starts with, believe it or not, a translation problem. See, when it comes to the internet, computers and us humans, well, we just don't speak the same language.
We get around the web using these easy-to-remember names, right? Like example.com. But the internet itself, the actual network, runs on numbers. These long strings of numbers called IP addresses. Think of them like precise coordinates on a global map. So the very first challenge is, how does your computer take the name you type and find the right number?
The answer is something called the Domain Name System, or DNS. And honestly, the best way to think about it is as the internet's giant universal address book. It's this massive global database that takes the human-friendly name you give it and in an instant finds the machine-friendly IP address it needs. This is the absolute critical first step that points your request in the right direction. Okay, so we found the correct address. Awesome. But your request can't just be, flung out into the void. No, it has to be carefully and precisely packaged for the trip ahead. And this whole process follows a really strict set of rules, basically a standardized checklist known as a network model, like TCP/IP. You can think of these as the internet's universal packing instructions. They make sure that data is packed up correctly by the sender and can be unpacked perfectly by the receiver, and it doesn't matter what kind of computer or phone or server is involved. This packing process has a name. It's called encapsulation. First, your initial request is created. Then it gets wrapped with some extra info for reliability. And finally, that all-important IP address is attached, just like a shipping label. It's literally like putting a letter into an envelope and then putting that envelope into a shipping box. Each layer adds vital information for the journey. But wait, before that package even gets sent, there has to be a polite little introduction. Your computer needs to make sure the server on the other end is actually there and is ready to receive something. This is done with something called the TCP three-way handshake. It's a super quick three-step digital conversation. Your computer sends a little packet that basically says, "Hello, are you there?" The server replies, "Yep, I'm here and I'm ready for you." And your computer sends one last packet back saying, "Awesome, the data is on its way." This little exchange is what establishes a reliable connection, and it stops your data from just being sent out into the digital abyss. Now, that handshake is a key feature of TCP, the Transmission Control Protocol. Think of it like certified mail. It's a little slower, but delivery is guaranteed, and everything arrives in the right order. The alternative is UDP, which is more like a postcard. It's incredibly fast, but there's no guarantee it'll get there or in what order. So for loading a web page, you absolutely want TCP's reliability. But for something where speed is everything, like a live video stream or an online game, UDP is definitely the way to go. All right, so our data is packed, it's addressed, and the connection is set. Now it's finally time to hit the road. We're going from the local network streets to the global internet superhighway. So the journey begins on your local area network, your LAN. That's just your home or office Wi-Fi. From there, it might have to cross a citywide network, a MAN, before finally hitting the wide area network, the WAN. And that's the global internet itself. It's a clear progression from local streets right onto the main highway. Now, two key pieces of hardware make this jump possible. First, a switch directs traffic inside your local network, kind of like a mail sorter in an office building. But the router is the gateway. It's the on-ramp that takes our little data packet from the local road and launches it out onto the internet. So once we're on that internet superhighway, our packet is facing a maze with literally millions of possible paths. How in the world does it know which way to go? It all comes back to that digital shipping label we put on it earlier, the IPv4 header. This header contains all the crucial info, but most importantly, it has that final destination IP address. This whole pathfinding process is called routing. Routers all over the world are constantly talking to each other, using these incredibly complex algorithms to make decisions in tiny fractions of a second. The global routing system is basically the GPS of the internet, always recalculating the fastest, most efficient route for data to take. And these routers use two main strategies to figure out the best path. With one, it's kind of like asking for directions turn by turn. Each router only knows about its immediate neighbors.
With the other, it's more like having a complete GPS map of the whole system. Each router sees the entire network layout. Both are designed to solve the same problem, finding the best path through the absolute chaos of the internet.
So after hopping across countless routers, sometimes spanning entire continents, maybe even zipping through undersea cables, our little data packet, it finally arrives.
Arrival. The destination server gets the packet and starts unwrapping all those layers we added to get to your original request. But here's the thing. The journey is only half over. Now, the server finds the web page you asked for, packages all of that data up, and sends it on the exact same high-speed journey right back to you.
In this entire round trip, your request going out, the web page data coming all the way back, this whole journey we've just spent the last few minutes explaining happens, on average, in about 0.15 seconds. It is literally faster than you can blink. And that just perfectly illustrates the invisible, unbelievably complex, and just astonishingly reliable system that powers our digital lives. Billions of these tiny, intricate journeys are completed flawlessly every single second, connecting every single one of us across the globe. But here's the kicker. This whole system was built on a foundation, IPv4, that only has about 4.3 billion addresses. In a world with tens of billions of connected devices, we've basically run out of room. And that challenge is what led to the creation of its successor, IPv6, a new system with an almost unimaginable number of addresses, ensuring the internet's invisible journey has plenty of room to grow for generations to come.